Okay, rational numbers. Rational numbers are denoted by the set Q. Okay, we represent rational numbers using set Q. Okay, so rational numbers are numbers that can be written in the form A over B, where A and B are integers and B is not equals to 0. Okay, so this is the definition for rational numbers. Numbers that can be written in the form A over B, where A and B are integers and B is not equals to 0. If both A and B are positive, then A over B is called a proper fraction if A is less than B. So examples of a proper fraction. Can you give me some examples of a proper fraction? If A is less than B.
2 over 5.
2 over 5, yes. Any more? 1 over 3, any 1 over 3, 1 over 8, these are known as unit fractions. If you have a 1 on the top there, this is known as the unit fraction. Okay, all unit fractions are proper fractions. Okay, then it is if A over B, it is called an improper fraction if A is greater than B. For example, 7 over 6, 5 over 4. These are all improper fractions. What about this number? Is this proper or improper?
Whole number.
Is it a whole number? 7 over 7 is equals to 1. Yes, 1 is a whole number. But when I write it like this, it is in the form of a fraction. Okay, it is written as A over B. A is 7, B is 7. So now it is in the form of a fraction. So we must know whether it is proper fraction or improper fraction. Okay, so it belongs here. 7 over 7 is improper fraction. 7 over 7. Okay. Okay, a whole number is B divides evenly. If B divides evenly into A, then it is a whole number. Okay, all right. Okay, but this is not called a whole number. This part of it is called a whole number. This is still an improper fraction. Okay, so this is what we mean by rational numbers. So whenever we say rational numbers, think of fraction. In other words, any number that can be written in the form of a fraction is a rational number. If you cannot write the number in the form of a fraction, then it is not a rational number. Okay, let's look at this table here, the side here on my right hand side here. This number 5, can we write 5 as a fraction?
Yes.
How would we write it as a fraction?
As
5 over 1.
Yes, good. 5 over 1 fraction. So is this a rational, if this is a fraction, is this a rational number?
yes.
Yes. It's 1 over 8. This is already in fraction form, 1 over 8. Is this a rational number?
Yes.
How about this number, 1.75? Is this a rational number?
Yes.
No.
It can be.
Why do you say yes?
Because 1.75 it can be
Written as?
107 over 100.
Yes, very good. And then we can simplify this as?
Rational number.
If we simplify this, what do we get?
7 over 4.
7 over 4, yes, very good. Even if we leave like this, it's okay. So we know that 1.75 can be written as a fraction. Because it can be written as a fraction, it is a rational number. How about this number? 0.001.
1 over 1000.
Yes, good. 1 over 1000. This number is also equivalent to 1 over 1000. You divide by 1000 will give you 0.001. So this is also a rational number because you can write it in the form of a fraction. How about this negative 0.1? Rational or non-rational?
Negative 1 over 10.
So rational or not?
Rational.
Yes, it is a rational number. Any number that you can write as a fraction is a rational number. How about this third square root of 4? Can you write this as a fraction?
Square root 4 minus 2.
Okay.
It's also equal to
2 over
2. Yes, so this is a rational number. How about square root 2?
1. Impossible.
Yeah, you cannot write this as a fraction, cannot. So this is not a rational number. So from this table, what can we deduce? What can we say? What can we generalize? What can we generalize? What kind of a number is 5? Whole number, right? It's a whole number, right? 5. So what can we say about whole numbers? Can we say that all whole numbers are rational numbers?
Yes.
Yes?
Yes.
Okay, what other generalizations can we make from here? All, from here we also can say that all integers, all integers are rational numbers. Okay? All natural numbers, okay, all natural numbers are rational numbers. Okay, so if Q represents rational numbers, if W, say whole numbers are represented by W, integers are represented by, what's the letter that we normally use to represent integers? Z, natural numbers, N. So if we give these letters for this kind of numbers and we want to show their relationship, we can draw a Venn diagram. Okay, so what is inside what? Okay, we will start from the first circle. What is the first circle? Okay, let me draw something like this for you first. Okay. Okay. Okay, so this is what we're going to draw. Okay. Okay, so this, what is right inside? We have 4 types of numbers here: Q, W, Z, and N. N is natural numbers, Z are integers, W is whole numbers, and Q is rational numbers. So which one is inside? Okay, natural numbers start from
0 to infinity.
whole numbers.
1 to 9 and 0.
Okay. Integers are negative and positive numbers. Negative and positive numbers. Okay. And then we have rationals. Right inside here will be, this would represent the N set. Sorry, we're doing this the other way around, right? Whole numbers start from 0 to 1 and all that, right? Natural numbers start from 1, 2, and 3, correct? So this is natural numbers N. Next will be your W. N is inside, N is a subset of W. W is a subset of integers, and all numbers, okay, all whole numbers, integers, natural numbers are all subset of rational numbers. This is Q. And rational numbers is a subset of real numbers, R. Okay, so this is how it is. So R, or all real numbers, okay, all real numbers, they consist of 2 types of numbers only. That is rational numbers and irrational numbers. These are rational numbers and these are irrational numbers. Inside rational numbers, you have whole numbers, integers, natural numbers, all inside here. Everything that's not inside here is inside irrational numbers. Together, they constitute all of real numbers. Okay? Can I understand until now? Okay, so far? Any questions?
Okay.
Okay, so we're going on to the next subtopic. We're going to see how we can use highest common factor to find fractions in the simplest form. Okay, we have done this before, right? Do you remember this, that we have done this before? When we did prime factorization, using highest common factors to reduce fractions. Okay. Okay. If you have a fraction, say A over B, and this fraction, the highest common factor for this highest common factor is 1. That means this fraction is in the reduced form. It is in the simplest form, or you say lowest term. Okay, if the HCF is 1, highest common factor. If you cannot divide it by any other number except 1, that means this fraction is in the reduced term. Okay, so now let's look at some other examples. Okay, we want to reduce 24 over 30. Okay, so how do we do this? If we want to use HCF, the first step is to find the prime factorization of 24. So 24 will be 6, 4. This is 2, 3. You remember this? 2, 2. So 24 is equals to 2 multiplied by 2 multiplied by 2 by 3. Or we can put 2 to the power of 3 times 3. Yeah? Okay. 30 will be 6 times 5. 6 is 2, 3 and 5. Sorry, class. Give me 1 minute there. No? Ini ada kelas sekarang. Okay. Okay. Oh. Okay, okay. Okay, bye. Okay, so 30 is 6 times 5. So 2, 3, 5. So 30 is equals to 2 times 3 times 5. Okay. So here, from here, we know that we have the same factors here, 2 and 3. So you can either draw the Venn diagram, or straight away we know from here that HCF is 2 times 3, which is 6. So to reduce this fraction, 24 over 30, we divide both of the numbers by the HCF, okay? So what do we get here? 24 divided by 6 is 4, and 30 divided by 6 is 5. So we have reduced it. Now if you check this fraction, the highest common factor of this fraction is 1. Therefore, it is in the reduced state, okay? So we have used HCF to reduce this fraction to its lowest term. Okay, Ken?
Yes. Yes.
Okay, one more example, okay? 300 over 144. So what do we do now? We need to do the prime factorization for 300. 300 will be 100, 3. 100 is 10, 10. Is it to 10, 10? 2, 5, 2, 5, 3. Okay, so 300 is 2 times 2 times 3 times 5 times 5, correct? And then you have 144. 12 times 12. 12 is 6 times 2. 6 is 2, 3. Okay, 6, 2, 6 is 2, 3. So 144 is equals to 2 times 2 times 2 times 2 times 3 times 3. All right? Okay, so you have 1, 2, 1, 2, 3, 3. Here no 5s, okay? So HCF for 300 and 144 is equals to 2 times 2 times 3, which is 12. So we reduce this fraction by 12, okay? So this is 300 divided by 12, 144 divided by 12. What do we get here? 25
over 12.
12, yes. This is an improper fraction, but it's okay. Okay, we can still reduce it like later. To simplify it more, we change it to mixed numbers, okay? So this, if you change this to mixed numbers, usually we leave our answer like this, 1 over 12, okay? But we have reduced the fraction to the lowest term possible already, okay? Then only we change to a mixed number. So this is how we reduce the fraction, okay? By using HCF. And I'm sure you still remember how to find HCF using prime factorization, okay? So we have finished with using HCF to reduce fractions. Okay, so next subtopic that we are going to look at is complex fractions. Okay, complex fractions. A complex fraction is a rational expression that has a fraction in its numerator, denominator, or both. In other words, there is at least one small fraction within the overall fraction. You have a fraction inside a fraction. That's the complex fraction. So there are three types of complex fraction. Either the complex fraction is in the denominator like this. Okay, here the complex fraction is in the denominator, or the complex fraction is in the numerator, or the complex fraction is in both the denominator and the numerator like this. All of these examples are known as complex fractions. Okay, can understand this? Okay, so now we are going to simplify complex, see how we can simplify complex fractions. Okay, okay, say we have this example. Simplify. You're given a complex fraction like this. In this case, okay, I'll give you another example first. Say you have 2 over 3 over 4 over 9. Simplify this. How do you do that? Simplify this. But the first step is to take the denominator and multiply it with the reciprocal of the denominator. Okay? To reduce. Multiply the numerator okay. In case you have forgotten, denominator is the number on top. Sorry, numerator is the number on top. Denominator is the number at the bottom. Okay. So to reduce or to simplify this fraction, all you have to do is to multiply the numerator with the reciprocal of the denominator. That means the salingan, salingan untuk penyebut. Okay. So 2 over 3 times by the reciprocal of 4 over 9 is 1 over 4 over 9. Okay, reciprocal of 4 over 9 is 1 over 4 over 9. 1 over 4 over 9 is 9 over 4. So times by 9 over 4. So we simplify this. We have 3 over 2. Okay, can understand? Okay. Okay, another example. Simplify 2 104 over 3 3 over 5. First step, change it into fractions. Change this fraction into fractions. You have 9 over 4 over 18 over 5. Change this to fraction, change this to fraction. Now you want to simplify this. So the numerator is 9 over 4 multiplied by the reciprocal of the denominator. That means 1 over 18 over 5 gives you 5 over 18. Okay. So 1, 2. So your answer is 5 over 8. Okay.
Okay.
Yes, no? Can I? Okay, one last example, okay? Calculate x given that x over 10 over 4 over x is equals to 8 over 5. Okay, you want to find what is x. So first thing is to simplify or reduce the fraction on your left hand side. To do this, you have x over 10 multiplied by the reciprocal of 4 over x is x over 4 is equals to 8 over 5. So you have x squared over 40. X times x is x squared. 10 times 4, 40 is equals to 8 over 5. We want to eliminate 40, so we multiply this by 40. Right hand side by 40. If you left hand side, if you multiply the left hand side by 40, then you must do the same thing on your right hand side. So we eliminate the 40 here. Here 40 divided by 5 is 8. So we have x squared is equals to 64. X is equals to x is equals to square root of 64, which is plus minus 8. Okay. I'm sure you already know how to do all these things. Okay. This is just refreshing only. Okay. Just letting you know what is complex fraction. Maybe before this we didn't know that this was called complex fraction. So now we know that. Okay. So far so good. Can understand?
Yeah.
Yeah.
Can Okay. Last subtopic. We're going to continued fractions. Okay, this one you must listen very carefully. Okay, it's a little bit difficult. Okay, continued fractions. One minute, I just need to open up something. Okay. Okay, I'm going to do the example first before we look at what is continued fraction, because this is a little bit complicated. Okay, so let's do one example first. Okay. Find the continued fractions representation of 415 over 93. What kind of a fraction is this?
Improper.
Improper fraction. Yes, improper fraction. Okay. So we are going to find the continued fraction representation of 415 over 93. Okay. So we start with 415 over 93. We know that this is 4. If we divide this will give you 4 plus 43 over 93, correct? Okay, but if you divide and you get the decimal value for 415 over 93, this value is 4.4624. Okay, this is the value, decimal value when you divide 414 over 93. So if you write it out in fraction, this is the quotient when you divide 415 by 93, this is the quotient and this is the remainder of 43 over 93, okay? Okay. Okay, so we also know that 43 over 93 is the reciprocal of what? 93 over 43, right? Songsangan, salingan, 43 over 93 is the reciprocal of 93 over 43, okay? And 93 over 43 is actually 2.1628, which means it is approximately 2, correct? It's approximately 2, okay? But 93 over 43 can also be written as 2 plus 7 over 43. That means you have 2 times 43, 93, and remainder 7 over 43. Until here, are you clear? Are you clear until here? Okay? If you're not clear, tell me.
Is this almost like Euclidean algorithm?
Yes, it is. It follows the Euclidean algorithm, yes. If you have read up something, then I know you can follow. But then how about the others? Okay, is this first line correct? What I've written here. Is this correct? Number 1. Correct, right? You just, all you have to do is divide 415, divide by 93, you will get 4. What do you times 4 times 3 is 12. 2, 1, 9 times 4 is 30, 6, 37, okay? And your balance will be 43. So you can write this as 4 plus 43 over 93, okay? So because 43 over 93 is the reciprocal of 93 over 43, we just take this for example first, okay? So 93 over 43, we know it is 2.1628, which is approximately 2. Or we can also say that 93 over 43 is 2 plus the remainder is 7 over 43. If this is like this, then we know that this 415 over 93 is also equal to 4 plus 43 over 93 is the reciprocal of 1 over 93 over 43, correct? 43 over 93, this one is also equivalent to 1 over 93 over 43, correct? So if it's 1 over 93 over 43, then it's 1 over 93 over 43, we say is approximately equals to 2. Then we can say that this is plus 1 over 2, right? Remember, this is the actual value. So we are still near there, and we haven't gone very far. Okay, so now it's 4 plus half. Okay, so now we look at 7 over 43. Okay, we know that 7 over 43 is the reciprocal of 43 over 7, correct? And 43 over 7 is equals to 6.1429, which is approximately 6. Okay, 43 over 7 can also be written as 6 plus 1 over 7. This is approximately 6. Okay, so that means what? That means this one, that means now, just now we wrote is approximately equals to 2, right? So now we can write it as 1 plus 1 over 2 plus 1 over 6. Okay?
Wait, what? Why?
Why? Because, okay, this is this. So this is 1 over 4 plus 1 over 2, right? Okay? So now, instead of saying this is 1 over 2, This is 1 over 2. Now we're looking at this number, right? 2 plus this. So we have 2 plus, isn't it? 2 plus, this is 7 over 43. Okay? 7 over 43. So we get this, and it's like this 6 plus 1 over 7. So it's this approximately 6. So this here, if you want to go and nearer, closer still, then it's actually 2 plus, because we have this one, right? 2 plus 7 over 43. 7 over 43 is the reciprocal of 43 over 7. Okay, so we want to write this as 2 plus 1 over 6. So this part here is actually this part, 7 over 43. Is this part here. 2 plus this, 2 plus this. So it's 2 plus 1 over 6. Do you understand that?
I think I can understand.
Okay, let me just finish it first. So now we have 1 over 7 here, okay? So 1 over 7 is the reciprocal of 7. Okay? So, but 7 is equals to 7 plus 0, 1. No more remainder here. So we don't need to continue anymore. So we can stop here. Okay? So we can stop here already. So this is also equal to 4 plus 1 over 2 plus, instead of just writing 6, we write 6 plus 1 over 7. 6 plus 1 over 7. But 1 over 7 is the reciprocal of 7. So we stop here. 6 plus 1 over 7. Okay, so this number can be, so that means this number 415 over 93 can be written as a continued fraction like this, or we can say 415 over 93 is equivalent to, use this bracket, the first integer here is 4, so it's 4 semicolon, and then it is, we're going to look at the others like this, 2, 6, 2 and 6. This is 2 semicolon 2, 6. Okay. So this is the way of trying it, either this way or this way. This is the first integer here. Second integer here is here, and then the third integer here is here. So 4 semicolon 2 comma 6. Okay. So this one here, I'm just trying to explain to you why we keep taking the reciprocal. Of course, I will show you another way which is much easier for you to do. But I just want you to understand why we're doing it this way. So do you think you understand this?
Okay.
A little.
Anybody? How about the others?
Just a little bit, madam. Not everything.
You want to do it again?
Um,
Okay, let me show you the other method first. Okay, say you want to reduce or simplify this number. Okay. 137 over 33. Okay, you want to represent this as continued fraction. So we know the 137 over 33 is 4 plus 5 over 33, correct? How do we get this? 137 divided by, 137 divided by 33. So we get 4, remainder 5 over 33. Now we take the reciprocal of this. 5 over 33, reciprocal is 33 over 5. 33 over 5 is 6 plus 3 over 5. So we repeat until we don't get a remainder, okay? So 3 over 5, the reciprocal of 3 over 5 is 5 over 3. 5 over 3 is 1 plus remainder 2 over 3. 2 over 3 reciprocal is 3 over 2. 3 over 2 is 1 plus 1 over 2. 1 over 2, the reciprocal is 2 over 1. 2 over 1 is equals to 2 plus 0 over 1. Once you reach 0 here, then you stop. Okay? So, therefore, 137 over 33 is equivalent to
Four.
is actually 4 plus 5
1 over.
over 33, right?
Yes.
But 5 over 33 is
Reciprocal.
equivalent to 1 over
6.
6,
6 plus 3 over 5.
5.
This is also equivalent to, 4 plus
1.
1 over
6.
6 plus 1 over
1.
1 plus,
1 plus 2 over 3.
2.
yes, 2 over 3.
2 over 3.
And this equals to 4 plus 1 over 6 plus 1 over 1
Plus
1 plus
plus 1 over
1
1.
over
1
1
plus.
plus 1 over 2.
Yes, correct. So this is your answer. Or another way of writing this is, you can write this as like this. So the first integer here is 4 colon, and then we look at these numbers here, 6,
6.
6,
1.
1, 1.
1.
6, 1, 1. Like this. So this is the two ways of writing it. Okay, I know this is a little bit difficult, a bit confusing if you can't see clearly, okay? That's why you need to understand this first, okay?
Okay.
Okay, let me do one more example for you, okay? Okay, example, 11 over 7 is equals to, you tell me, 1 plus, what's the remainder? 11 divided by 7?
4 over 7.
4 over 7.
Yes, 1 plus 4 over 7. So next line will be?
7 over 4.
Yes, 7 over 4 is equals to?
1 over
1
3
plus 3 over 4.
4.
Okay, next line?
4 over 3.
4 over 3 is equals to?
1. 1 plus 1 over 3.
Good. Next line?
3.
3 over 1 is equals to 3 plus 0 over 1. So we stop. So 11 over 7 is equals to
1
1 plus
1 over 4 over 7. 1 plus
1 plus 4 over 7.
1 over 1 plus 3 over 4.
Okay, sorry, yeah, I think I missed one step here for you. Okay, you can write it like this also, okay? 1 plus 4 over 7. So this is 1 plus 1 over 4 over 7 is 1 plus 3 over 4 equals to 1 plus 1 over 1 plus
1
1
over
over
1 plus 1 over 3.
1 over 3, and then is equals to 1 plus 1 over 1 plus 1 over 1.
Already, okay, we stop.
Oh, I done it already, yeah? Okay, we can stop already. We don't have to do this last line, because we've already reached here, okay? When we come until here, we can stop already, okay? So this is the answer, or, okay, 11 over 7 is equals to 1. Here is
1,
1 and
1.
1, okay?